And welcome back to another video. We're starting off today with Fluorine looking at an electron, saying he has got to get one of those. Fantastic. So remember, electronegativity is the ability of an atom to attract the electrons within a bond towards itself. Atoms with high electronegativities have a greater pull on electrons than atoms with low electronegativities. So we saw fluorine has the highest electronegativity. It has a greater pull on the electrons than atoms with a low electronegativity like hydrogen. This unequal sharing of electrons creates a polar covalent bond. It's a covalent bond because they're sharing electrons, and it's polar because they're not equally shared. So here we can see this is like an electron cloud, which is like a bond between these two atoms. Most of the time the electrons are around the fluorine, so it's got this negative charge, and hydrogen has this not a full positive charge, we call this a slight positive charge around the hydrogen. Okay. If the electrons are shared equally, then it's a nonpolar covalent bond. So it's still a covalent bond, they're still sharing electrons. Nonpolar means they're shared equally. Electrons are shared equally between two atoms with the same electronegativity value. For example, H2, Cl2, O2, and N2. Basically, molecules that have the same atom, so for example, two hydrogen atoms, they're sharing their electrons. Each of them has one electron. They're sharing them to have a full outer shell to make H2. They've got the same electronegativity value. The electrons are shared equally between them to make a nonpolar bond. Okay. Notes. This is basically what I've gone over in the past two slides. If you can just pause the video and write this down, and this is the only notes for the video, so don't hate me. Again, most importantly, unequal sharing of electrons creates a polar covalent bond. If they're shared equally, then it's a nonpolar covalent bond. That's the two key points I wanted you to get out of this. Unequal sharing of electrons, polar bond. If they're shared equally, then it's nonpolar bond. Okay? Great. So we saw this table, and this is another representation of it, but here we have a new thing. We have this arrow. So we saw this before. We saw hydrogen is slightly positive because it's got a low value. It can't attract the negative electrons towards it. Chlorine is slightly negative because it's got a higher value, meaning it can attract the electrons towards it. And we can represent this by this. This arrow is called a bond dipole. The plus of the arrow goes near the positive element because it's positively charged, and it's pointing towards the more electronegative element. I'm going to put this video on the Google Classroom because it's kind of interesting, but this is just another way. There's a plus sign here signaling the positive end of the bond. It's the less electron density region. It's the positive end of the molecule with this slightly positive sign. The arrow points towards the more electronegative atom. More electron density, the negative end of the molecule with this slightly negative sign. So this will be your task in Google Classroom. I'm going to set up something like this. Assign bond dipoles and partial charges to these bonds, and say if they're polar or nonpolar. So, for example, HCl, for all of these molecules you have to do something like this in your books. Bond dipole here, positive end of the molecule pointing towards the negative end of the molecule. And write these partial charges in. So actually this won't be in Google Classroom, this will just be a task for you to do in your books, which I will put on Google Classroom as well, but not as like an assignment. These molecules in your books, draw them out like this with these partial charges and bond dipoles on them. You can use this table or any other table you find online to fill it out. And I'll also put this video up on the Google Classroom for you to watch if you're still a bit confused. Okay, thanks guys.